Hello, my name is Fergie, and today I'm going to introduce to you about our final project in Big Data, which is about bike sharing demand system. And I'm doing this project with my friend. As you can see here, there are two of us who are doing this project. And so now I'm going to give you some introduction about what bike sharing system is. And I believe you already heard about this, you already knew about this because there are more than 500 different programs currently operating in various cities about this bike sharing system. And so, bike sharing system is a service in where bicycles are available for shared use. So I can say that this one bike, it can be used by more than one user. And when you rent this bike in a certain location, you can return it to another location where you are or where you want to go. So when you move on to another location, you can return it to another location. So you can go straightly to the Kaggle website, www.kaggle.com, or you can see it here up here. They provided more about the description of this bike sharing system or this bike sharing demand. They also provided the data. You can get the data from this website. And so after we downloaded the data that is provided by this Kaggle team, we then observed this data, and we found that this training data set, oh by the way, the data set is in CSV format. And in this training data set, it contains the first 19 days of each month, and the testing data set, it contains the 20th to the end of the month of two different years, which is the 2011 and 2012. And the training data, it has 10,886 observations with 12 variables, and the testing data, it has 6,494 observations with 9 variables. We provided to you the dataset description. You can see in the left column or the first column 12 different variables or features. All these variables you can find in training dataset, but in the testing dataset it doesn't have these two variables, the casual and the registered variables. It only has 9 variables or features. In the right column you can see the description about each of the variables. Now let's move on to the system flow or the project flow or the research steps. We divided our flow, our project, into 4 different steps before we get the expected result. The first step is the data collection. Here we collect the data by downloading the training and testing dataset that I said before has been provided by the Kaggle team. And after we downloaded the data, we pre-process the data. We found that this dataset has some missing values. So we pre-process by replacing the missing values with certain value, which we choose to be 0. So all the missing value we replace with 0. And after we replace the missing values, we done the feature engineering. In this step, we do the data factorization and we create new data frame. We then convert the data set, the date time of the dataset feature into timestamp so that the operation performance of the data would be easier. And after we done this feature engineering, we built the model of this dataset or the predictive models. We use 2 different predictive models, which are random forest and neural network model. And I'm not going to give you much explanation about these 2 models. I'm just going to give you or I'm just going to explain a brief about these models. Random forests are an ensemble learning method for classification, regression, and other tasks. And it is operated by constructing a multitude of decision trees at training time and outputting the class that is the mode of the classes, or we can say the mean prediction or regression of the individual trees. And the neural network is a family of statistical learning models inspired by biological neural network, and it is used to estimate or approximate function that can depend on a large number of inputs. And after we done these 4 steps, we get the expected result which is we provided furthermore in this project. Here you can see how we apply the random forest model and the neural network model. This is some of the part of our code. It's only to give you some description or some introduction to you about how we apply the random forest and the neural network model in our project. And then we provide to you the result of our project since we have finished the project. And here are the 2 different models, the result of 2 different models, the random forest and the neural network. You cannot say or you cannot see significant difference between these 2 because each model, it's the result of the model, it depends on how you build the model, and how we build the model, this is the result you can see. The big difference or the significant difference is you can see only here in the early morning in random forest and neural network are a little bit different, and also in Saturday and Sunday the number of bike rented are a little bit different. And the last result of our project is we visualize the data. So there are 4 visualization of the data set. The first one here, the A picture, is about we are trying to relate the feels like temperature, the wind speed, and the humidity into this plot, only to show the relationship between these 3 different variables. And in the B picture here, you can see we are trying to visualize the data based on weekdays and weekends. And in this C picture, we are trying to visualize the data based on season and also the time of day and the weekdays or work days and weekends. It's also the same for the D picture, only we use this or we visualize this based on weather. There should be 4 different weather, but since the heavy weather only have 1 row in the data set, so we combine it with the light weather here. So you can only see these 3 weather. And we can conclude that, or we can say that the number of bike rented or people will rent bike depends on season, on temperature, on weekdays or weekends, and also depends on weather. So these 4 factors or these 4 variables has significant influence to number of bike rented from day to day. So that's all for our introduction to our final project. I hope it will help you in your learning. Thank you so much for watching.